Let us continue carboxylic acids. In the carboxylic acids chemical properties we will see. Now in the carboxylic acids, the OH bond involving chemical reactions. This bond involving chemical reactions we will see. Okay. Now reaction with the sodium. Now carboxylic acid we are taking. It is reacting with the sodium. So what is a reaction possible in the sense sodium gives electron, that electron is taken by this hydrogen, this bond is shifting like this hydrogen takes this electron and becomes hydrogen gas, this O takes this bond becomes RCOO minus, then this sodium becomes Na plus. Okay, so carboxylic acid with sodium gives hydrogen gas. Okay, then carboxylic acid with the sodium hydroxide we'll see. Now carboxylic acid we are taking, then sodium hydroxide we are taking Na plus OH minus, Na plus OH minus. This OH minus takes this H plus and becomes water. This bond is shifting to this O minus, this bond is shifting to this O, therefore that becomes RCOO minus Na plus sodium carboxylate and water. Sodium carboxylate and water we are getting. Then carboxylic acid with the sodium carbonate. What is the reaction? We'll see. Carboxylic acid with the sodium carbonate. Sodium carbonate, what is the reaction? Okay. Now, when acid is added into carbonate, carbon dioxide gas will be released. Sodium carbonate will give carbon dioxide gas in the presence of acid. Which acid in the sense? The acid acidic strength is equal to or greater than carbonic acid. That acid can liberate carbon dioxide from carbonate. Okay. So, which acid, if you add acid into carbonate, it will give carbon dioxide. Carbonate gives carbon dioxide in the presence of acid. Which acid means? That acid acidic strength is greater than or equal to carbonic acid. Okay, that acid if you add, then carbonate will give carbon dioxide. So which acid and all is coming in that category, in the sense carboxylic acids coming in that category, and mineral acids. Mineral acids in the sense HCl, H2SO4, HNO3, perchloric acid, these and all. Okay, HCl, HBr, HI. Okay, so carboxylic acid is added into this. So this carbonate will give carbon dioxide. Carbonate will give carbon dioxide. This carbonate is giving carbon dioxide. Okay, so now we will see this carbonate, will see carbon and 3 oxygens will see. Carbonate structure we are writing. Carbonate in the sense we can write CO3 2 minus. Now carbon valence shell is having 4 electrons because it is 4th group, and CO3 2 minus, therefore for 2 oxygens will give minus 1. This oxygen is having minus 1 means it is having 7 electrons in the valence shell. Then this oxygen also is having 7 electrons in the valence shell. This oxygen group number is 6, therefore this oxygen is having 6 electrons in the valence shell. 6 electrons is there. Next, what happens we will see. Now, between carbons and oxygen, how the bond is possible, in the sense here double bond is possible, because this oxygen is having 6 electrons in its valence shell. It is in need of 2 electrons to get octet, therefore it goes for double bond. It is having 7 electrons in its valence shell, it will make one bond to get octet. Okay, it is also making one bond. Okay, next, how the reaction takes place, you see that. Now here bond migration, this lone pair is migrating to this place, therefore this bond is migrating to this place, therefore it is becoming what means carbon dioxide. Now this carboxylic acid, okay, in this carboxylic acid this bond will migrate, from here H plus comes. That H plus, this oxygen, this O minus, it is taking bond means become 2 minus. This O 2 minus and H plus becomes what means H2O. Okay. I take another carboxylic acid to get H plus. Okay. This carboxylate anion takes Na plus and becomes sodium carboxylate. Sodium carboxylate. Okay. Sodium carboxylate. Therefore, when acid is added into carbonate, we are getting carbon dioxide gas. Okay. In the same way, bicarbonate. In the same way, bicarbonate. That bicarbonate reaction we'll see. Now we'll take carboxylic acid and sodium bicarbonate will take Na plus HCO3 minus. Here also So bicarbonate also will give carbon dioxide in the presence of acid as like carbonate. Okay. Now this bicarbonate you will see in the bicarbonate central atom is carbon and three oxygen atoms are there. This bicarbonate is oxy acid. Oxy acid means it will have OH group. Now this minus charge will give to one oxygen. Now we will give electrons. Carbon group number is 4a. Therefore this valence shell is having 4 electrons. O minus valence shell will have 7 electrons. Therefore 7 dots. O will have 6 dots. O is having 6 dots, we can say. So this O is having how many dots in the sense 6 dots. Hydrogen is having 1 dot. Okay. Now we will see the bonding. We'll see how the bonding will be there. We'll see. Here double bond will give. Here single bond will give. Here single bond will give. Here single bond will give. Okay. This is a bicarbonate we said. Now how the bond shift will take place, we'll see. This lone pair converts into bond pair. This bond pair converts into this oxygen. This bond pair converts into this oxygen. Therefore, this H plus takes this OH minus and becomes water. This will become CO2. That will become CO2. Then this is RCOO minus Na plus RCOO Na. RCOO Na. Okay. So we are getting like this. Sorry. So bicarbonate gives carbon dioxide gas. Okay. Then carboxylic acid with ammonia we'll see. Carboxylic acid reacting with the ammonia. That point we'll take. Okay. So now we'll take carboxylic acid. Ammonia we will take. We are taking ammonia. This is having lone pair. Nitrogen is having lone pair. Okay. So how the reaction takes place here? Now this nitrogen lone pair is donated to this hydrogen. This bond is shifted to this oxygen. Therefore, we are getting a RCOO minus. Okay, this O minus is having 3 lone pairs. This nitrogen takes this H plus and becomes NH4 plus. This nitrogen takes H plus and becomes NH4 plus, we can say. It is called ammonium carboxylate. This is called what in the sense? Ammonium carboxylate, we can say. This ammonium carboxylate on heating, what happens? This ammonium carboxylate on heating, what happens? That we will see. This ammonium carboxylate on heating, what happens means this bond is migrating here. This lone pair is attacking here. Okay, this lone pair is attacking. Then this bond is migrating here. Okay, here lone pair will be there. That lone pair. Sorry, first point we will see. First we will see one step. We will see here. This bond is this lone pair attacking. This bond is migrating. Therefore, it will become what in the sense so and so. So here what will be there means this ammonia will be there. Ammonia will be there. Next step, what is the next step means it is attacking here. Then this is shifting. This is attacking here. Okay. So what we will get, we will see RCO NH2 NH2 here. Here what happens means this bond will migrate this side. Okay. Therefore here double bond will not be there. Single bond will be there. Here minus charge will give. Here 3 lone pairs will give. Here positive charge will give. Okay. Next step we'll see. Next step lone pair becomes pi bond. This bond is shifting. Therefore, water is leaving. So what we are getting in the sense RCONH2. Amide we will get. We are getting amide. So okay. So carboxylic acid on treating with ammonia, acid-base reaction takes place. It is acid, it is base. So we are getting ammonium carboxylate. On heating, what happens means we are getting amide by losing water. It loses water and gives amide. Okay. So carboxylic acid with ammonia on heating gives acid amide. We can say it is amide. It is what it is means amide we can say. Then carboxylic acid with the diazomethane will take. Okay. Carboxylic acid with the diazomethane CH2N2 with the diazomethane, what is the product we'll see. Carboxylic acid with the diazomethane, what product we will get, that point we'll see. Diazomethane we'll see first. Diazomethane contains what we'll see. It is diazomethane. Diazomethane we have given. Okay, here one lone pair is there. Here also one lone pair is there. So how the reaction is possible? That point we'll see. Okay, what is the reaction? That point we'll see. Now lone pair is shifting here. This bond pair is shifting here. Therefore, we'll get this CH2. This carbon is having lone pair, negative charge. This N, triple bond, N, lone pair, here positive charge. It is called diazomethane. Okay. So we have written diazomethane. We have written this diazomethane is attacking carboxylic acid in what way? That we'll see. So now we'll take carboxylic acid. We are taking carboxylic acid. We are taking this oxygen is having two lone pairs, we can say. Now this lone pair is attacked here. This bond pair is shifting to this oxygen. Therefore, what it will become, you will see carboxylic acid becomes carboxylate anion. Carboxylic acid becomes carboxylate anion. Then we will get here CH3, this N2 plus, CH3 N2 plus we will get. Okay. We will see the next step. Next step what happens means this O minus is attacking this carbon. This bond is shifting here. Therefore, we will get RCOOMe. Methyl ester will get. We will get what in the sense methyl ester. N2 is liberated. Okay, we are getting what in the sense methyl ester. This is methyl, it is ester. So methyl ester we are getting. We are getting methyl ester in this case, we can say. Okay. Sorry. Next, so far we have seen in the carboxylic acids OH bond we have seen. Now we will see CO bond we will see. Okay, in the carboxylic acid, we will take carboxylic acid like this. Which bond involvement in the sense this bond involvement we'll see. Okay, we'll see the chemical reactions in which this bond is involving like this we'll see. Now, one reaction carboxylic acid will take. We'll take the reagent PCl3 or PCl5 or SOCl2 like this reagent will take. What is a product in the sense RCOCl, acid chloride. We are getting acid chloride will take. We will get PCl3, PCl5, SOCl2. Whatever the reactant you take, whatever the reagent you are taking, you are getting acid chloride you are getting. Okay. So next carboxylic acid with alcohol esterification we'll see. Esterification. So now we are taking carboxylic acid, then we are taking alcohol. What is a product in the sense ester? Ester is a product and water. In the presence of what in the sense? In the presence of acid is the catalyst. In the presence of acid is the catalyst. So how the reaction takes place here, that we will see. What is the reaction possible here? That we'll see. We'll see the mechanism of the reaction. Now we are taking carboxylic acid. We are taking carboxylic acid. Now H plus is attacking. H plus attacks what means this oxygen. So we'll get oxygen is having positive charge now. Okay, like this we are getting. What is the next step means alcohol is attacking. Next step is attacking of alcohol. It attacks this carbon. This bond is migrating. So we'll get RCOH. Here two lone pairs will be there. Here OH. Alcohol is attacking here. Here positive charge will be there. Okay. Next step. We'll go for next step. This bond is shifting here. So now we will get RCOH. Here OH. Here OR. Okay, H plus is leaving. H plus is leaving. Now H plus is attacking. H plus is attacking which one in the sense this oxygen. Okay. So now we will get RCOH. Here OR dash we will say from alcohol it is coming. Okay, here OH2, here lone pair is there, positive charge is there. What is the next step? We'll see. This bond comes here, this bond goes here, therefore water leaves. So we'll get RCO O R dash. We'll get, okay, and H plus leave. Here H plus is attacking and H plus is leaving. Therefore, it is catalyst. Okay, catalyst involves in chemical reaction and at last it leaves. Okay, it fastens the chemical reaction. So we got ester. So in this ester, so ester in the sense how to round off water molecule means from carboxylic acid OH group, from alcohol hydrogen. Okay, from carboxylic acid OH group, alcohol hydrogen leaves as water. Like that we can say. Next, next reaction, carboxylic acid with P2O5. What is the reaction? Let's see. Carboxylic acid with P2O5, phosphorus pentoxide on heating. What we are getting? That means phosphorus pentoxide is a dehydrating agent. Phosphorus pentoxide is a dehydrating agent. Therefore, it removes water from carboxylic acid. It removes water from carboxylic acid. So, how the water is removed? That point we'll see. Here C11O, here like this. Here what happens means water molecule is leaving like this. Okay, this bond is shifting. This lone pair is attacking here. Therefore, we will get anhydride. We will get RCO, OCO, or anhydride. We are getting plus water. So we got what in the sense we got anhydride. We got acid anhydride. Okay, so carboxylic acid with P2O5, carboxylic acid on heating with P2O5, we are getting acid anhydride. We are getting. Okay, so carboxylic acid on heating with P2O5, we are getting acid anhydride. We are getting. Okay, so next we will see carboxylic acid. We will take carboxylic acid with the Cl2 and red phosphorus. With the Cl2 and red phosphorus, carboxylic acid with the Cl2 and red phosphorus. Here carboxylic acid is having alpha carbon, therefore alpha hydrogen is there. If alpha hydrogen is there, then only reaction will be possible. Okay, if alpha hydrogen is there, then we will say reaction is possible. This reaction is called HVZ reaction. HVZ reaction. HVZ reaction means in the carboxylic acid, alpha hydrogen is replaced by chlorine. Okay, alpha hydrogen is replaced by chlorine. Therefore, CH2Cl, COH. Alpha hydrogen is replaced by chlorine. Then again alpha hydrogen will be replaced by chlorine. Again alpha hydrogen is replaced by chlorine. Then again alpha hydrogen is replaced by chlorine, we can say. Okay. So in the HVZ reaction, alpha hydrogen is replaced by chlorine, we can say. This is called HVZ reaction. Okay. So in the we can take, instead of chlorine, we can take even bromine also. If we take bromine, in the place Br will come. Okay, alpha hydrogen will involve in the chemical reaction. HVZ reaction in the sense alpha hydrogen will involve but not other hydrogens. Okay, suppose we are giving bromine and red phosphorus. So what will happen means alpha hydrogen will be replaced by bromine but not other hydrogens. Okay, so alpha hydrogen is replaced by halogen. HVZ reaction means alpha hydrogen is replaced by halogen, we can say. So and so products possible. Okay. Beta hydrogen will not involve in chemical reaction. Beta hydrogen is not involving in chemical reaction. Only alpha hydrogen is involving in chemical reaction. Now we will take the reactant Me3C COOH. Now we will give bromine and red phosphorus. So we have given HVZ reaction reagent we have given. What is the product we will get? Okay, so here how many products we will get, do you say? For this case we got 3 products we got. For this case we got 2 products. For this case what, how many products possible do you think? How many products possible for this? Shall we say 1 product or many products? What do you say? Okay, so think and say regarding this. So now we will go for next reaction. So next reaction is what means Claisen-Schmidt reaction. Claisen-Schmidt rearrangement. Claisen-Schmidt rearrangement. Okay. Claisen-Schmidt rearrangement. We are taking Claisen-Schmidt rearrangement. We are taking. Okay. Now Now we will see in this reaction. In this reaction, how many products possible do you think? No product is possible. Why no product? Because it is alpha carbon. Here alpha hydrogen is not there. No alpha hydrogen. Alpha hydrogen not there. Therefore no HVZ reaction. If alpha hydrogen is there, if alpha hydrogen is available, then only HVZ reaction is possible. Otherwise no. Okay. Sorry. Next we will say Claisen-Schmidt rearrangement. In this rearrangement, we will take carboxylic acid. We will take this carboxylic acid. We will treat with what in the sense hydrozoic acid. HN3 is called a hydrozoic acid. We can say hydrozoic acid. Okay, in the presence of mineral acid, sulfuric acid. So, what is a product possible here? That we will see. Okay, sir. So now hydrozoic acid, how it will be there? That we will see. Hydrozoic acid contains H, N, 3 N present, 3 times nitrogen present. So now we will give electron dots. We will give hydrogen is having 1 electron, nitrogen is having 5 electrons. Nitrogen is having 5 electrons. Okay, nitrogen is having 5 electrons. So nitrogen is having how many electrons that we have given. So now we will give the bonding. Now we are going for the bonding. Here hydrogen bond. Here nitrogen is going for bond. Here nitrogen is going for the bond. How in the sense how the bond formation is possible here in the sense these 3 electrons I will write it as 1 electron here, rest of the 2 electrons here. Okay, so how the bonding will be there? That means here 1 bond will be there, 1 dative bond will be there like this. Okay, 1 dative bond will be there like this. Now we have given like this. Is it correct or wrong? It is wrong. Why? Because nitrogen is not having vacant orbital to take dative bonding. Nitrogen is not having vacant orbital to take dative bonding. Okay, for this nitrogen lone pair and like this 2 electrons will give. For this 5 dots we have given like this possible. Okay, for this nitrogen vacant orbital is there, not there. For this nitrogen vacant orbital is there. Okay, therefore dative bond. For this nitrogen how vacant orbital is there, that we'll see. For this configuration is what means helium. Now 2s2 2p3. That 2p3 I will write like this. Okay, for this nitrogen 2p3. This unpaired electron has gone for this single bond. This vacant orbital has gone for this dative bonding. Okay, so for N3H hydrozoic acid we have given like this. This dative bond we will write it as normal covalent bond by giving formal charges. Here lone pair, here double one, here double one, here 2 lone pairs. Okay, for this negative charge, for this positive charge. It is hydrozoic acid. This hydrozoic acid will give, it is giving H plus. It is giving H plus in the sense how it will be there. This bond pair is shifting, therefore it gives H plus, and N3 minus how it will be there. That we'll see. It is what in the sense N3 minus you can say. It is what in the sense N3 minus. Okay, it is N3 minus azide ion. We will say it is N3 minus. We will call this as azide ion. We will call azide ion. We will call. Okay, this azide ion is attacking carboxylic acid in what way? That we will see. Now we will take carboxylic acid. Now we have taken carboxylic acid. Azide ion is attacking. Before azide ion is attacking, H plus is attacking this carboxylic acid. Okay, H plus is attacking this carboxylic acid. That reaction will take. So carboxylic acid we have taken. Now this H plus is attacking this carboxylic acid. So here attack like this. So we'll get like this. Okay. Now this azide ion is attacking. Azide ion is attacking like this. Bond shift like this. Okay. So water leaves. Therefore R C double one O. This N3 minus will give like this. N3 minus we have given like this. Okay. So this is called acid azide. It is called acid azide. We will call acid azide is uptime. Then next step we'll see. Next step. What is the next step? That point we'll see. We'll go for next point. This bond is shifting here. That means here itself, this lone pair is shifting here. Then this bond pair is shifting here. Sorry, okay. Now also we'll shift like this. This lone pair is shifting. This bond pair is shifting like this. Like this we'll take. So what we'll get in the sense RCO, N is having two lone pairs, single bond plus charge, single bond. It is having one lone pair. Here three bond pairs. Here negative charge will be there. Okay, like this is there. It is converting like this. Next, what happens? You see that next this bond is shifting like this. That means N2 leaves. So we are getting a RCO. N is having two lone pairs. This is called a nitrene, we can say. Nitrene. If nitrogen is having 6 electrons in its valence shell, it is called nitrene. This nitrogen is having two lone pairs, one bond. Therefore, 6 electrons in its valence shell, therefore nitrene. It is acyl group. RCO is called acyl group, therefore it is called acyl nitrene. Acyl nitrene, we can say. So this step on warming, N2 is leaving, so we are getting acyl nitrene. This in this acyl nitrene, what happens means this R is taking this bond pair and goes to this nitrogen. This lone pair is shifting. This step is slow step, slow step. Therefore, it is rate determining step. Rate determining step. Here, rearrangement is possible. This R is taking the bond and goes here. Therefore, we are getting O double bond C, double bond N, and single bond R. Isocyanate we are getting. Isocyanate. This we will take for hydrolysis. This on hydrolysis, what is a product we will get, we will see. This on hydrolysis in the sense this bond is breaking. Here H plus, here OH minus. Then this bond is breaking. Here H plus, here OH minus. So this part becomes what in the sense RNH2. RNH2 we can say. This is carbonic acid. Carbonic acid will convert into carbon dioxide and water. Okay. Carbonic acid. It is H2CO3. H2CO3 will give carbon dioxide and water. Okay. So we are getting primary amine. So see that this carboxylic acid is treated with hydrozoic acid. This carboxylic acid on treating with hydrozoic acid, what is a product? Okay. This carboxylic acid on treating with hydrozoic acid, what is a product in the sense? This R takes this N and becomes RNH2. Okay. This is leaving as carbon dioxide. Okay. So R takes N and becomes RNH2. Primary amine we are getting. It is called a Claysen's chemical reaction. Here intermediate is a acyl nitrene. It is a intermediate. Acyl nitrene is the intermediate. Rate determining step is this migration of R minus from carbon to nitrogen is called rate determining step. Okay. We'll go for next reaction. Ant Eistet reaction. This naming reaction we'll see. We'll take carboxylic acid. We are taking carboxylic acid. This we will treat with SOCl2, thionyl chloride. So thionyl chloride means how the reaction in the sense this bond is breaking, this bond is breaking. So here SO, here Cl, here Cl. Therefore it is SO2 will be removed, HCl will be removed. It is RCOCl. So we are getting what in the sense RCOCl we are getting. Then it is reacting with what in the sense diazomethane. It is reacting with what in the sense diazomethane. So now we will take diazomethane will take and RCOCl will take. So now we will take RCOCl and diazomethane will take. And in the diazomethane we are taking like this. Okay. Diazomethane we have taken like this. Now this lone pair is attacking this carbon. This bond pair is attacking this O. So we'll get RCO minus. Here CH2, here N2, here N2. Okay, like this is it. What is the next step that we will see? We are going for a next step now. In the next step, which comes in the sense, another diazomethane comes, another diazomethane. Another diazomethane comes here. This C minus is subtracting H plus. H plus subtracting, therefore it becomes C abstracting H plus. Therefore becoming what we will see, CH3 N2 plus, like this. Okay, like this it is becoming. It is becoming like this. Here what happens? In this place what happens, that we'll see. In this place what happens, that we'll see. This bond is migrating. This bond is migrating. It is attacking this. This is migrating. Therefore it becomes CH3Cl. This becomes N2. Okay. So what is the remaining here, that we'll see? RCO, RCO, CH minus, CH minus, then N2. N2 will be there. Okay. N2 will be there. So this is there. Now from here what is leaving? From here what is leaving, that we'll see. This bond is shifting, therefore N2 leaves. So we'll get RCO, RCO, CH. Here one lone pair will be there. Okay. Now this carbon is having 2 bonds and 1 lone pair. Therefore this valence shell is having 6 electrons. So this is called carbene. It is called carbene. This carbene is the intermediate in a Reimer-Tiemann reaction also we have discussed. Okay. So we got what, in the sense carbene we got. Okay. Next, this carbene is treated with what, in the sense silver oxide. Silver oxide, it is going for rearrangement. What is a rearrangement here, that we'll see. What type of rearrangement is possible, that we'll see. This R is taking this bond and going to this place, attacking this carbon. Okay, attacking this carbon. So what we will get, in the sense RCH, RCH, RCH will get. Then while this lone pair is going to this place. Okay, lone pair going to that place. Therefore double bond C, double bond O. This is called what, in the sense ketene we will say. This is called ketene. Okay, this ketene we will convert into different products on treating with the different reagents. Okay, so we will convert into what are the products, that we'll see. This ketene we are taking RCH double bond C, double bond O we have taken. First this we will treat with water. This on treating with water, what we will get, that we will see. Okay, so now we'll break this bond. This side will give H plus, this side will give OH minus. So we'll get RCH2 COOH. Okay, this is one possibility. Okay, next reaction we'll see. Next, treating with the alcohol. Treating with the alcohol. Now what will happen, in the sense, now RO minus this side, H plus this side. Alcohol means H plus this side, RO minus this side. So the product is RCH2 COO dash. Ester is the product. Next, we will treat this with ammonia. So how the reaction will be there, we'll see. So this side H plus, this side NH2 minus, this side NH2 minus. So we'll get RCH2 CONH2. Amide we will get. Okay. Next, treating with the primary amide. Treating with the primary amide. How it will be there, we'll see. Treating with the primary amide. H plus this side, RNH minus this side. Therefore, we will get RCH2 CONH R dash. Secondary amide we are getting. Okay. This is about Arndt-Weisstadt reaction. So Arndt-Weisstadt reaction means, what is a reactant? Carboxylic acid is the reactant. This carboxylic acid we are converting into what products, you see? We are taking carboxylic acid. Carboxylic acid is the reactant. In the Arndt-Weisstadt reaction, carboxylic acid is the reactant. Now, this R is there, COH is there. In between these two, what is introduced? CH2 group is introduced here. In this case, in between these two, CH2 is introduced, this H is replaced by R dash. So in all the products you see, between this R and CO, between R and CO, CH2 will be introduced. One CH2, here CH2, here CH2, here CH2. Then this OH will be as it is here. In this OH, this is converted into OR dash. This OH is replaced by NH2. This OH is replaced by NHR dash. Like this, different products we are getting in this ONT A state reaction. So next we will see oxidation. We'll see oxidation of carboxylic acid. We will take. Now we are going for oxidation. We'll take carboxylic acid or CH2, COH. Carboxylic acid we have taken. It is taken for oxidizing agent, mild oxidizing agent. What in the sense H2O2. Here beta hydrogen is going for oxidation. In the presence of hydrogen peroxide, beta hydrogen goes for oxidation. So beta hydrogen goes for oxidation. Therefore, we are getting like this. Beta hydrogen goes for oxidation. Therefore, we can say this beta hydroxy acid. Beta hydroxy acid. It is alpha carbon. It is beta carbon. Beta hydrogen goes for oxidation. So we will call this as beta hydroxy acid. We will call. Then selenium dioxide will take oxidizing agent selenium dioxide. Now what we will get? We'll see. Alpha carbon undergoes oxidation. How the oxidation is there? See here that both hydrogens converting into water. This alpha carbon, both hydrogens converting into water. This carbon becomes keto group. This carbon becomes keto group. Okay. Alpha carbon becomes keto group. Therefore, it is called alpha keto acid. We can say it is called alpha keto acid. So carboxylic acid on oxidation with hydrogen peroxide, mild oxidant, we are getting beta hydroxy acid. With the selenium dioxide, on heating gives what in the sense alpha keto acid we can say. So then we'll see ring substitution. We'll see. Now we'll take carboxylic acid. Carboxylic acid we'll take. We are taking benzoic acid. Ring substitution in the sense bromination. We'll say bromine and halogen carrier. Phenyl group will go for halogenation in the presence of halogen carrier. Okay, it is electrophilic substitution reaction. It is electrophilic substitution reaction. Here electrophile is Br plus. Carboxylic acid is electron withdrawing group. Therefore, it is meta director. So at meta position, electrophilic substitution takes place. Electrophilic substitution takes place at meta position. Then carboxylic acid going for sulfonation. Sulfonation in the sense take sulfonating agent corn sulfuric acid and sulfur trioxide you take. Here electrophile is SO3. This electrophile is attacking meta position. Therefore, sulfonic acid comes to meta position we can say. Sulfonic acid goes to meta position. Sulfonic acid goes to meta position we can say. Then we will take nitration. We will take nitration in the sense we have to take nitrating agent. Corn nitric acid plus corn sulfuric acid is the nitrating agent we will take. At meta position, nitro group comes. At meta position, nitro group comes, we can say. So nitro group comes to meta position. Okay. Then these carboxylic acids do not undergo Friedel-Crafts reaction. Why? Sir, what is the reagent for Friedel-Crafts alkylation? Friedel-Crafts alkylation means CH3Cl and AlCl3. Okay. Friedel-Crafts alkylation means reagent is alkyl chloride, alkyl halide and aluminum chloride. Why it is not going for? Why carboxylic acid? Why benzoic acid is not going for Friedel-Crafts alkylation? What is the reason? Here, what is the reason in the sense why it is not going? What is the reason? That means this phenyl ring is not active enough to undergo electrophilic reaction here. Therefore, Friedel-Crafts alkylation or Friedel-Crafts acylation is not possible with aromatic carboxylic acids. So, aromatic carboxylic acids do not go for Friedel-Crafts alkylation or Friedel-Crafts acylation. So, okay. We'll go for next reaction. We'll take alpha hydroxy acid. We'll take alpha hydroxy acid. This alpha hydroxy acid on heating, it is going for cyclization. We are getting what in the sense cyclic diester. We are getting cyclic diester. The cyclic diester name is what in the sense lactide. Okay, alpha hydroxy acid on heating gives what in the sense cyclic diester. Okay, now we will take this alpha hydroxy acid. We will take, suppose we are taking R CHOH, COH. It is alpha hydroxy acid. Alpha hydroxy acid we have taken this on warming gives cyclic diester.